In the last video, we started talking about functions, and in this part, let's start talking about some differences in functions that come with programming languages versus when we actually do it in math. Now, first things first, we should probably talk about what a parameter is to a function versus what an argument is. So there is a little bit of a distinction there, even though it might seem like they're interchangeable. Remember in the last video that we said that there's basically a couple parts to a function. So there's a return type, and then there's a name. So here I'm just going to call a function f, and then it's going to take in, let's just say, some integers here. So let's say int x, int y. Should probably put a bigger space there, and then we have a body, right? So this part here, the part between the curly braces, is the body, which is just the actual code that we're writing. And then we had a return type. We had a name of the function so that we can actually use it, and then we have this part here, which these would be the parameters, which are the things that we will be able to use the function with, to be able to call it with. And then we said that there's an extra part to a function, which is just its actual usage. So somewhere in main, let's just say this is like some free floating code somewhere, we would say maybe like f34, and what this will do, we said, is just jump to wherever this is located in the code and run the body with x being equal to 3 and y being equal to 4, and it creates those variables and we're able to use them. Now the distinction here is that these are parameters and these are arguments. Parameters are ones that are in your declaration / definition. They're the variables that you're going to be using in the function. The arguments are for a specific instance of a function. So whenever you call a function and you give it either variables that you're going to be passing to it, or you're giving it literals like I am here, the numbers 3 and 4, things that you can directly see and tell what they are without having to know about what the variable contains, then those are called arguments. And I mostly mention that because if you look things up or if you get into computer science, there is a bit of a distinction between those two things. Anyways, we should probably start talking about some differences here with parameters in how we use them as opposed to math, because these aren't just strictly mathematical thinking. We actually have this on a machine, right? So there are some physical things that may happen when we use these. And so namely, we talked about in the previous video, if I had something like this, int main, and then I use a variable x, let's just say it's an integer, x, and then I call f of x, let's just say, and then I write f up here. So we'll say f just returns an integer for whatever reason. It takes in an integer. And here, all this does is it does x equals x plus 5, and then returns x. What we said was that this x here, this x in the f function, use a different color, is different than this one, right? Is what we said. So these are different. And on top of that, we also said that any sort of changes that you do to the x in f, because it is different, won't happen to the x that's in main. And same thing goes if they had different names as well, right? Like if I called this one y here in main and still called f with it, anything that happens to x, even though y is kind of like the one that's being filled in for x here, right, is what we said, it's not actually going to reflect anything when main happens, or when it gets back to main. So if I was to see out y here, what we said would happen is, if I, let's just say, gave y a value here and set equal to, let's say 2, then the, oh, I didn't even finish writing this, return x. Not that it matters that much. What I said here was that main is going to see out 2, even though if we follow the execution of this code from the start of main, it would create y, set it equal to 2, it would go to f and give it y, which is 2, it would set x, which is the variable that represents this parameter here, x is equal to 2 plus 5, which is 7, and then it would return 7. However, y would still be 2 when we get back to main, because any sort of changes that happen in the function do not happen to the variables that you are giving to the function. They don't change it. But there is a way that we can be able to do that. Actually, let's leave this here. And we can do that by simply changing the way that we give the parameter list. So, so far we've done what's been called a pass by value. And so if I create a variable with the right type, int, let's just say func, and it takes a variable x, and then this one, let's just say equals x plus 2, and then it returns x. This one is a pass by value, and an alternative to this is a pass by reference. So here I'll just create a variable called func2. It will take an int, and the way you specify this is by ampersand x. And we put that there, put this here, and if I now wrote basically the same exact code and did a return of x, this one is actually going to modify the code. So this one here, if this one is pass by value, this one would be pass by reference. And let's take a closer look at what that means with a picture here. So if I was to go and be in main, and call that first function that I had, so func, I guess I need a variable first to demonstrate it. We'll create an integer called x, and then I called func, and then I ran it with x, and then down here I ran it again with func2 of x. There's a distinction in the way these two run. So the first one here was the pass by value, which we just said we write normally, and we'll write this in the code in a moment. What this does is it says, okay, as far as what this line does, this integer x, maybe I should set it so that we don't have a compiler error. Let's just say int x equals 2. What this line does, right, what a variable declaration does is it says, okay, the computer is going to go create a variable called x, and it's going to make it 2. So somewhere in memory, which is your RAM, it's going to create a variable called x, and it's going to give it 2, and that's great. What happens when you call this one, this function here, is that it's going to make a duplicate of x. So it's going to say, okay, well, I'm going to make a copy of this and assign the value that was in that variable to a new space. So this is the one that exists inside func. This is a new x. It's a completely different copy of it. And this is why whenever we do any sort of changes to this, like when we earlier went and said, okay, this is x equals x plus 2, it will go and look at this copy and say, all right, that's 5 now. And then anything that you do with this copy will happen as if you were using a normal variable, but it doesn't affect anything that happened to the original copy of the variable, because this main, this one up here, is the x in main, and this is the one in function. So this would be our pass by value, and it will quite literally pass the value. So it will make a copy of the value and assign that to the new variable. And again, the names don't have to match, even though I'm calling this x and the one x in here. If this was called, v instead, then it's still going to make a copy, and it's going to take the copy of whatever is in that variable v and copy it into the x that exists in the function as a parameter. So it quite literally takes the 2 and plugs it into that variable there by making it into a new variable. Now, this second version, pass by reference, does not make a copy. So this version here, this func2 that we wrote earlier, has the ampersand, it passes by reference. What this will do instead is we still have that variable v that has a value of 2 in it, but when we pass by reference, what this will do is it is going to just quite literally say, okay, the function now has access to look at this. It's called a pointer, and when we call func2 for x, it will say, all right, x is not a specific value, it's not just going to copy it, but x is going to point to whatever is there. So x is going to get a reference, which is what this little arrow represents, it's called a pointer, to the variable. Now, without overcomplicating with all this technical stuff, what this essentially means is that if you pass a value or pass a variable by value, then anything you do to it will not be reflected once the function ends. So here, when I add x plus 2 and then return x, when I get back to main, the value of v is still going to be its original value of 2. However, after I call func2, it's going to be 4, even though I am in a function and x itself is dying because it's going out of scope. This function, because it is passed by reference with this ampersand, is going to physically change it. So if I was to see out v after this, it would be 4. It physically, anything that you do in that function will be reflected once you return. Let's take a closer look at this in the actual code itself. Okay, so I've gone ahead and written the code for the functions that we just wrote on the board there. I have created the two variable declarations up here, the function prototypes, and then here I'm going to call with a variable called myVariable. I'm going to print what it is at the start, and then we're going to call it with that first one that's going to pass by value, and then we're going to see what it is afterwards, and then we're going to do the one that passes by reference with a little ampersand, and we're going to check what it is. And just so you can see my code, it really is just the same one that we wrote previously. So it just takes x equals x plus 2. It's going to print what it is in that version of the function. Here I just called it v1 and v2. And then it will return x, which we're just going to throw away and not use. So let's take a quick look at it here when we run it. And so you can see here we have the output from our previous example in the last video, but it says my variable at start is equal to 7, and then in the context of the function x plus v1, it added 2 to it, right, is what we said that the code is going to do. I should have put an end line after this to make it a little easier to read, but that's okay. It's going to take x and equal it plus 2, so it takes 7 plus 2, which is 9, and then after the function v1 has returned, it's still 7. So consider that it was 7 in main, got set 7 here, and then after the function call was over, it's still 7 even though we added 2 to it in the function. And that's because it's passed by value, which simply makes a copy of it. Here though, you can see that x plus 2, v2, does the same exact thing. It adds 2 to it and makes it 9, and it prints it in the context of that function. But afterwards, we can see that the value is 9 when we get back to main. So my function after function v2 is 9 after calling this version 2 of the function that passes by reference, this one right here. And that is because of this ampersand, this reference, and it will quite literally send the exact pointer to this variable. It knows exactly where it is in memory, and it will overwrite anything that does to it. So the first version makes a copy, the second version gives the variable itself. Finally, let's talk about one last thing, which is scope. And we've discussed this a little bit when it came to if statements, but scope really starts to apply when we're talking about functions. And you might remember we've mentioned global scope before when creating variables that are outside of main. Any sort of function that we write is generally going to be in a global scope in that you can use it anywhere you want. And so scope is basically just defined as where the variable is allowed to live. Here for an example, I'm going to create a variable and I'm going to call it int variable, let's just say, equals 4. In my main here, I'm going to see out this variable now. Just see out variable and then throw an end line. And while I'm at it, let's throw an end line on these so that our output looks a little nicer. And so what we expect here is that variable will just be 4. So I've put it here at the global scope. I've just created a variable called integer variable and set it equal to 4. And so this will print 4. I'm not going to bother running it. It will print 4. However, we can actually overwrite this variable in name only. So we can keep the variable and kind of just not be able to use it in the scope. So whenever you see a scope, it's basically going to be whenever you encounter curly braces. And so what I could do here is I could create another variable. I'm going to use an entirely different type as well, just for the sake of the example. I'm going to create a float called variable, and I'm going to equal it to 4.7. Let's actually make it something like 6.7, so it's very different. Now, what's going to get printed here is going to be 6.7. Even though there's already a variable that exists with 4 as its value here, I am in a new scope, specifically main. I'm in main scope, and if I create a new variable with the exact same name, then I am going to be able to use that variable in this current scope. If I go ahead and run this now, you'll see that it is in fact 6.7 that gets printed. I can overwrite the names of variables and just have them exist with some sort of new meaning. This is especially important with functions because now we're creating a bunch of different scopes. Here, I haven't created a variable called variable in my function f. I have created one in main, but I haven't created one in f. So if I was to see out variable in f is equal to, and then I put variable and then end line, what this one will do is it will look for the most recent occurrence of variable in terms of what's outside of it in terms of these scopes, these braces. So the float f is going to look inside of itself. So it's going to look, does f have a variable called variable? And then it's going to say, no, it doesn't. And so the next thing it will check is the thing that it's contained in. And the function f is in the global scope because there's nothing else containing it. It's not inside another function. It's not inside something like a class or a struct, which we haven't gone over, but we could put these inside of. So it's going to go to main, or sorry, not go to main, but it's going to go to global scope, and it's going to see there is a variable called variable there, and it's going to use that one. And so if I was to run this now, you should see that it will print variable in f is equal to 4, rather than the 6.7 that we see later. And the same thing would go if I called f down here as well, if I called like f with 2 and 7. This is still going to print the 4 rather than the 6.7. Right, so you'll see variable in f is 4 again. And so whenever you create a variable, it will look basically for the most recent occurrence in terms of things that are kind of layered inside of each other. So every time you create a new set of braces, then you're adding a new, basically, lifespan of a variable. And so the lifespan of a global variable is the entire program. It always exists. But whenever you create a scope like a function or an if statement or a while or anything else that uses these curly braces, then the variable only exists between those braces if you give it a new name. And you can always keep the name the same as the previous one, in which case it will just kind of ignore the old one, and you will be able to use the new one. If I wanted to do one final example with this, I could always say if true, so I'm just going to do kind of an arbitrary conditional here, it's always true. Then we could create a new variable called, let's just say, string x equals hello, and see out x. And here we'll just mark this with a x in if statements. And what we should expect to happen is that this will print hello. It won't print the variable. Oh, whoops, I wanted to call it variable. I'm sorry. Variable. Although x would work as well here. Variable. And I think I accidentally deleted the other variable. No, I didn't. This was right. The variable in f will be 4 when it gets here because it's going to look at the one in the global scope first. And you'll see it says variable is f and 4, or is 4 and f, like we said earlier. And then it says variable, the x in my function is 9. Variable in if statement is 9. And that's because I'm printing x, not variable. That's my bad. My mistake. Let's run it again. It should say hello. right? And it says variable and if statement is hello. So the reason it does that is because it looks in the most recent scope, which again is just these curly braces. If it finds a variable called that variable, great, it will use it. If not, it will look in the containing scope, the one that this if statement is in. In this case, that would be the f function. So this is, we have curly braces here, and so it says, is there a variable in there? No, there's not. Okay, well, I will go and try to look at the next one, and then it would go up to there if it doesn't find one. However, in this case, right, in the if statement, the first one that it finds is the string. Let's take a quick look at this with a diagram as well. Okay, so I've written a code fragment that's very similar to what we just wrote. Here I've created X in a couple different scopes. First things first, I've created an X at global scope. I've created one in main, and then I've created one in this if statement as well. And I've gone ahead and put colors next to them. So the global one is green, this one is blue, and that one's yellow. And I have a few uses of X here denoted in red with these numbers. I use X first here. So let's consider what this one's going to do. And it's going to maybe help if I draw a little bit of a diagram. So what we have is kind of self-contained little like Venn diagrams almost. So global scope is what everything contains. It's kind of like our universe. And then what we have here is we have main. So main is inside the global scope because main is declared in the program, and thus it must be a global scope because global is just the whole program. And then we have this if block here in the middle. And so at the global scope, I create a variable called X. I create something called main. At the main level, I create something called this here, this X. And then in the if statement, I also create an X, and it's the yellow one. Now, I could have more things in this Venn diagram. So if I had any other functions, they would probably be at the same level as main. They would be kind of floating here. And whenever we use a line of code that uses a variable, it will kind of search this Venn diagram and see if it can find the thing. I am simplifying it a little bit because there is some sort of context with the order of the lines as well, right? So here, when I call the first one, I think this is kind of a counterexample to that. This will print the green X. This one does the green X, that one up there. And so the reason it does that one is because if we consider at this line, it can't see the int main X yet because it hasn't been declared yet. And so it will search and it will see, is there any X that exists previously before this line? And it will say, okay, there's none in main because there hasn't been one created in main yet. So if we go in order of execution here, as far as the first line goes, the only one that exists is this one. It will check, is it main? And it says, no, it's not. And so it will check the one above it. And it says, okay, that's the X I want to use. And so that is why it uses the green one. It will search the braces outside of it if it doesn't find it in the scope that it is in. However, if we look at it, this first example here, this one, number one print, if I try to see out X on this line, X has been declared in main. So I have a line here that assigns 4.7 to a float called X. And so this one will be the blue one, this one right here. And again, if we consider what happens at this line, the X in main does now exist. So this first one will print the one in global scope. This one will create one in main. And then the next line will look, is there one in main? And it sees, yes, there is one. So it will use the one in main rather than the one in global because this line is in main and it sees a variable in main called X. If we look at this second one, it's going to be very similar to 0. This cout, so we keep going in the code. We get to if true, which isn't going to do any sort of variable declaration. We get cout X. And so again, there's no, this yellow X doesn't exist yet at this line here, this one with the 2 at it, because of the fact that it hasn't been created in this if scope. And so it will say, all right, I didn't find one in the if scope. I will try the next level above it, and it will see that there is one in the main scope. So it will say, okay, I'm going to use that one. And so this one would also be this blue X here. Lastly, we have this last one, where if we went and called it, it would now, again, in order of execution, after this cout, it would create this yellow X called hello, and it would move it there. And then now when it tries to look for a variable, it will check if first, and it will find one. So it won't keep looking into main and global, and this one will use the yellow X, which is from the line right above it. As a last example, if I was to cout X here, this one will use the blue one again. And the reason that it will use the blue one is this is no longer in the if statement. So if I was, again, going in order of execution, after this line, the if statement ends. And so this one dies. This whole square just disappears and is gone forever. So whenever you end a scope, you reach the right curly brace of a scope, it will kill anything that was inside of it. So by this line, this last line here, whenever I try to get x, the x from the if statement is dead, and so the only one that it's going to find is the one in main, and that's the one it's going to use. So this one will again be the blue one. I think that's a pretty good stopping point. Now we know how to use functions and use their parameters in different ways, and we also know a little bit about scope and where we're allowed to use variables. In the next part, we're going to take a look at a special kind of function that doesn't have to operate like a math function, and then it doesn't have to return a value. And then we'll also take a look at exactly why you would use functions in your code rather than just writing it all there, and some advantages to it.